Dear students of class 1 medical and non-medical and their respected teachers, today I am going to discuss a very important topic known as significant figures. Usually this topic is not discussed properly in classrooms. So what are significant figures? It is the number of digits which are certain and the last digit which is uncertain. The total number of these digits is known as number of significant figures of the given quantity. So what is its significance? More is the number of significant figures, more is the accuracy. So it means number of significant figures is the measure of accuracy of the result. So this is the important significance of measuring or noting the number of significant figures. So there are certain rules to find number of significant figures and hence know the accuracy of the given result. First rule, all non-zero digits 1 to 9 are always significant. That is, they must be counted while counting number of significant figures. For example, 785 number has 3 significant figures because 785 all the 3 digits are non-zero, so they must be counted. So it has 3 significant figures. Second rule, all zeros lying between any two non-zero digits are also significant. For example, 7008. Now these two zeros lie between two non-zero digits, so they must be counted. So this 7008 has 4 significant figures. Third rule, terminal zeros are not significant. Terminal zeros are not significant when there is no decimal point, but are significant when there is decimal point in the quantity. So for example, if we have 7500, there is no decimal point, these two terminal zeros are not counted. They are not significant. So it has only 2 significant figures. Or we can write it as 7.5 into 10 raised by 3, order of 10. So it will have 2 significant figures only. So terminal zeros are not counted when there is no decimal point. If there is decimal point, suppose 75.00, then it has 4 significant figures. So whenever there is decimal point, all the terminal zeros must be counted to get number of significant figures. Fourth rule, when a quantity is given with units, if quantity comes from measurements, for example, unit is given with the quantity, for example 7500 meter, then terminal zeros, there is no decimal point, but even then terminal zeros are counted. It has 4 significant figures. So when a quantity is given with units or the quantity comes from the measurements, then there is a unit written with the quantity, so then terminal zeros must be counted even when there is no decimal point. Then rule 5, for a given quantity less than 1, quantity less than 1, 0 before and after the decimal point are not significant. So we can leave the zeros before and after decimal point. For example, 0.007 has 1 significant figure only. All zeros before decimal point and after decimal point are not counted, provided the quantity is less than 1. Or it can be written as 7 into 10 raised by minus 3. So 10 to the minus 3 doesn't have any significant figure, so 1 significant figure will be there. Next, rule 6. So how to round off? So when we make calculations or some numbers are given, so you have to round off them. So there are certain rules to round off. When a digit is dropped, when digit to be dropped is greater than 5, so last digit which is to be dropped is more than 5, then previous digit is raised by 1. So ਜੇ digit drop करना है वो 5 ਤੋਂ ਵੱਡਾ है, तो previous digit ਅਸੀਂ 1 ਵਧਾ देना है. For example, x is equal to 6.87 given है, ਇਹ round off करना है. It has 3 significant figures, so in round off करना पर 2 significant figures ਦੇ ਵਿੱਚ. Now round off करके जो digit है which is to be dropped. 7 is to be dropped, but it is more than 5. So we have to increase the previous digit, that is 8. So by 1, so it will be 6.9. So x is equal to 6.87 when rounded off gives 6.9 because the digit which is to be rounded off is more than 5. If it is less than 5, then previous digit remains unchanged. ये 5 तो घट है फिर चेंज नहीं करना. For example, x is equal to 7.82. We have to replace 2 less than 5, so it is 7.8 after rounding off. Very easy. When digit to be dropped is 5. Greater than 5, we have to increase previous digit by 1. Less than 5, we have not to change the previous digit. But if the digit which is to drop is 5, then there are certain further rules. When 5 is followed by a number other than 0. For example, x is equal to 16.351. So we have to drop 5, but it is followed by number 0 more than other than 0, 1, 2, 3, any. So it will be, then previous digit will be increased by 1. So it will be 16.4. Digit is 5, but it has to be rounded off, not greater than 5. So it has to be dropped, but we have to see what is the next digit to 5. If it is other than 0, then increase the previous digit by 1. So it will be 16.4. Very easy. If it is 5 or followed by 0, 5 है, again 0 है, then there is no change. There is no change if the previous digit is even. We have x equal to 3.250. We have to draw 5 followed by a 0, or there is no 0. Then previous digit is, if it is even, it is not increased. It remains unchanged. And if it is odd, 3.350, it will be 3.4. This is the difference. So if the digit which is to be dropped is greater than 5, previous digit is to be increased by 1. Clear? If digit to be dropped is less than 5, then previous digit is not changed. If digit to be dropped is equal to 5, then we have to see whether it is followed by number other than 0, then increase the previous digit by 1. If it is followed by 0, but the previous number is even, then there is no change. And if it is followed by 0, but previous number is odd, then increase the odd number by 1. So this is all about number of significant figures. So when we have to make any mathematical operation, we add number of quantities, subtract, multiply, divide. The result so obtained cannot have the number of significant figures more than the least accurate factor involved in calculations, because number of significant figures is the measure of accuracy of the result. So if we combine 3, 4 or any number of factors, we add them, we subtract them, we multiply them, or we divide them, but the accuracy of the result or number of significant figures of the result so obtained after applying any mathematical operation, addition, subtraction, multiplication, or rotation, division, then result so obtained can never be accurate more than the least accurate factor involved in calculation. ਉਹਨਾਂ ਸਾਰੇ ਨੰਬਰਸ ਦੇ ਵਿੱਚ, ਉਹਨਾਂ ਸਾਰੀਆਂ ਟਰਮ ਦੇ ਵਿੱਚ ਜਿਹੜਾ ਸਭ ਤੋਂ ਘੱਟ ਐਕੂਰੇਟ ਹੈ, ਜਿੰਨੀਆਂ ਉਹਦੀਆਂ ਸਿਗਨੀਫਿਕੈਂਟ ਫਿਗਰਸ ਨੇ, ਉਹਨੀਆਂ ਸਿਗਨੀਫਿਕੈਂਟ ਫਿਗਰਸ ਤੁਸੀਂ ਰਾਉਂਡ ਆਫ ਕਰਨੀ ਹੈ ਜਿਹੜਾ ਰਿਜ਼ਲਟ ਸੀ obtain ਕੀਤਾ after any mathematical operation. So ਚੀਜ਼ ਯਾਦ ਰੱਖਣੀ. For example, if you have a cycle chain, if one of the links of cycle chain is weak, then chain cannot work. In other words, strength of chain cannot be more than the weakest link. Strength of chain cannot be more than the weakest link. जो weakest link टूट गया, chain टूट गई. Similarly, the result obtained from a number of factors, either by any mathematical operation, addition, subtraction, multiplication, division, the accuracy of the result so formed cannot be more than the least accurate factor involved in calculations. So this is all about significant figures. This is very, very important topic. So you can take screenshot of this. So I will give you the full screen. Then you can understand and you can practice few examples. So जे मेरी वीडियोज़ अच्छियां लगदियां तो प्लीज़ मेरे चैनल सबसक्राइब करो, अपने फ्रेंड्स नू, अपने क्लासमेट्स नू, अपने कुलीग्स नू, टीचर्स नू रिक्वेस्ट है मेरे नाल जोड़ो ताकि तुसीं फ्री दे विच घर बैठे फिजिक्स के कॉन्सैप्ट्स ने वो क्लीयर कर सको और अगे बढ़ सको। थैंक यू सो मच। गॉड ब्लैस यू ऑल, लव यू ऑल, थैंक यू।